And one of the things that I talked to you guys about the first day of class is that I said here that one of the things that I think is really beautiful about physics is that you can see the world in a way that nobody else can see. Like, for example, I talked about the rainbow. To me, the rainbow is more beautiful than somebody that doesn't know anything about physics. I know that when I look at a rainbow, I know that there's another rainbow to the right, which is an ultraviolet light. And I know that there's another rainbow to the left, which is an infrared light. That is really powerful thinking. So what I want to do here is that I want to do the same thing with an application of free fall. And what happened is that I was watching a television program with my in-laws. This was some years ago. It was a while ago. And they were talking about some fact. They were talking about a history of baseball. And I went like, wow, I know exactly what they're talking about. And I think that you will know what I'm talking about too. And it had to do that back in the late 1930s, there was there were not professional baseball teams at that time. They were called club sports. So there was the Cleveland Indians, which was a club sport. And what they did here is they dropped baseballs from a 700-foot building. So in other words, if I look at this building here, let's say I do it right here. So they had a building, and again, that's my ground. And what they found here is that they set up a building. They didn't set up a building, but there was a 700-foot building. So let's say that this is the building right here. And we know that the height of this building was 700 feet. And what they were doing here is that they were dropping baseballs. And what you found here is that the Cleveland Indians had two players that caught baseballs that were dropped 700 feet. And that turned out to be a world record. That was the world record for the highest baseball ever caught. I mean, that was dropped, of course, and then caught. So there was a guy from the San Francisco Baseball Club, which of course, you know, that becomes the San Francisco Giants in the future. And so he decided to attempt to break this record. Now, there's not a lot of information that's given. So again, here's the ground. And what they did here, and this is Joe Sprints of the San Francisco Baseball Club. And this was in 1939. So what he did is that to try to break the record, there was no building higher than 700 feet in San Francisco at the time. From what I understood is that they hired a blimp. So this blimp here had a higher height. So when you looked at the height of this blimp, it was 800 feet. Now, so they're dropping the baseball. And what they did here is that to make it, maybe I should write blimp here, just to be careful. And so what they did here is that they built this shelter. So they had this shelter here so that if Joe lost sight of the ball, he could immediately get under here and be protected. So when they were going to drop it, he was looking for the ball to be dropped, and then he would step out. And if he eyed it, he would catch it. And if he didn't eye it, he would just step underneath to protect them. And this is what the show stated. So the show stated this fact. What it said here is that on the 5th try, Joe tried to catch the ball. He saw it coming, but this is what they said here. They said that the ball was in the air for 7 seconds. And immediately my head went like, oh gosh, I know how fast that ball is traveling. Oh, I know how fast that ball is traveling. And what you find here is then in my head, I go, okay, I now have a question. How fast is the ball traveling when Joe catches it? So immediately I go into, free fall motion mode. I know that my acceleration is 10 meters per second every 1 second. So that tells me if the ball falls for 7 seconds, then the speed of the ball when Joe tries to catch it is 70 meters a second. And then my head just starts going off. And I go, but wait a minute, this isn't free fall. And because I know what the numbers mean, check this out. This is really 150 miles an hour. Now note, 150 miles an hour is way faster than any pitcher. But in my head, I immediately says, but this is with no air resistance. But with air resistance, which I could estimate it in my head here, I then say, well, with air resistance, if you have a 70-meter baseball, it now converts not to 150 miles an hour, but it turns out to be about 130 miles an hour. Okay, so I now know that the ball's roughly going about 130 miles an hour. Major league pitchers pitch at about 100 miles an hour. So 130 miles an hour is 30% faster. So that is a great, great speed. So this is much faster than a pitcher can throw the ball. So then here we go. So then I start asking a series of questions. I know that it's for 7 seconds. I know the acceleration due to gravity. I can estimate that speed. So all of a sudden, that gives me a lot of information about what's going on. Most people who don't have physics could never answer this question like this. But check it out. When Joe tries to catch the ball, what happens? The ball slams into the glove and hits his face. It breaks his jaws, if I remember correctly, into 12 pieces. I think he loses 5 teeth and he's knocked unconscious. That's not a surprise, right? It's 30 miles an hour faster, which is considerably more faster. And the sad thing is that he dropped the ball. But that's the beauty of physics. You can take these situations and you could make them more richer into what is going on.